Hey, welcome to my stream today. Sorry if there's a little background noise. Have my heater kick in just now, but today we are going to stream about streaming. And this topic I've covered a little bit before. Hey, Daniel, how's it going? I've covered this topic a little bit before, but back then I did not have a Scala draw. I probably did not a terribly great job of explaining it, and really it's been what I've been focusing on like the last couple weeks. And to be fair, a lot of focus has come in towards streaming recently because the recent React demos, and it's shown up definitely on like previous streams. So I thought it would be good to actually approach this with a explain it like I'm five kind of mentality. Yes, like honestly, that was the whole change, right? I've been trying to teach obviously, and being able to illustrate is huge. Yeah, streaming about streaming. It's an interesting topic because as many of you know, I've been pretty bullish on this one, but I think maybe it's not as cut and dry as I've made it out to be. Too. So we're gonna see some of the trade-offs. Gonna see what comes in with the territory when doing this kind of stuff. And but this is just me rambling right now, giving people a chance to join on. I think we're gonna cut over to this week in JavaScript pretty quick here. It's been a week. I'll say that. There's been a few big things. First of all, obviously, like Vercel. Like what have they been doing over there at Vercel? They've been hiring everybody up. I mean, if you've been on Twitter or checked anything, this is all everyone's been talking about, making jokes, even pretending like they got hired by Vercel. Jared Palmer, who did the mono repo, I think it's called Turbo repo. It was a recent hire, but the big one for me that I did not see, completely out of left field, obviously was Sebastian Marko. I can never say his last name properly, but seriously, that's huge, right? For those of you who don't know, Sebastian is core team member of React, and not just a core team member of React. He's largely seen as kind of like the kind of like the visionary behind it. Things like suspense and the whole throw the promise things have largely been credited back to him, and even just their whole vision in terms of concurrent rendering. And it's really interesting to see someone so core to the React team not be working at Meta. I don't know what that will mean for the future, but it's interesting that like such a vital member of that team is actually not working for Meta. I know this from working at eBay. Like there's a lot of pull that comes from like the company too, in terms of what features you get to look at, what you get to work on a little bit. They have real needs too. So you don't always get to do exactly what you want, what you think maybe is best for the community. So Vercel's like the opposite though. Vercel's mission is make things easier for developers. So that's a big shift, and might even kind of change the face of React. I think that's super exciting, even more than the fact that Vercel's picking everyone up. Yeah. Yeah, I don't know. Is it worrying about React? I mean, maybe this is a good thing. They started referring to themselves as the React org during React Conf, and I didn't really click on me, but they already probably knew what was happening. I think they realized that they were going to be spreading out. I mean, React's too good to belong to one company. I don't know. Maybe that's the mentality. Yeah, I mean, they've been picking people up like crazy. The big thing though is Vercel clearly has a mission, and their mission is to make stuff easier. They've been focusing on tooling, and like even with the pickup of Rich and Svelte, I feel like what they're exploring is how to create developer experiences that everyone would be enviable of, right? They kind of like, in a sense, like a lot of investment into Rust, a lot of investment into these build tools, and I think that's their aim. I don't know if I don't know if UX for them comes nearly as important as DX. Obviously, you can't have one without the other, but I think in terms, if you look at who they'll hire, that was the interesting thing about Seb, because as I said, he is like largest seen as the core of React, and that he lesser fits the mold than some of the other recent hires. So I think it's really interesting to see where that goes. But yeah, so I mean, that was probably the biggest thing. Then there's a lot of cool technology stuff that I saw. I don't know, did any of you see this demo? I'm just going to throw this up on the screen here, but it's kind of related to the topics we're talking about today. But Jacob Ebe, who works for Remix, was playing around with seeing how fast he could get assets fired over, and essentially he's using something called what are they called? Preload headers, essentially. Instead of quite often you can put tags in the head of your document which do preloads, but you can also set them in the headers so they can even get processed before any HTML goes over the wire. And this is pretty good, especially when it takes a while to render your document. Like, let's say you're doing a bunch of data fetching and you don't have streaming, which I'll get into in a minute, then it takes a while for you to respond with HTML. It's possible to flush your headers early if you want to, and that way start preloading your assets before you send any HTML. I actually was playing with this feature myself, and unfortunately, I didn't see the same sort of gains. I was getting the same performance I was getting with streaming, but I definitely perked my interest. It's possible that he's using this in combination with another feature, which is called early hints, which isn't, they let you flush part of the headers ahead of time. One of the biggest challenges is once you flush the headers, like, you're kind of done, and that's your last chance. So a lot of times you want to wait till you know the status of your request before you flush the headers. But with 103 response, which is this early hints, it's possible to start flushing these asset headers before you're comfortable even setting the status. And he might be using this in combination to see these kind of gains, but it's really cool. One of the hardest parts, and one of the reasons that we even look at streaming, is kind of the front load, the asset loading. And I'll get more into that in a minute. We'll come back to this demo, but I thought it looked really cool. And it's definitely worth checking out. If see it, I'm going to actually post this in chat right now in case you didn't get to see this. It might be a little small on my screen, but there you go. And what else was kind of cool on technology side? Yeah, some stuff been going on in the MPA side of the world. Yeah, where was it? They've been, we talk a lot about multi-page apps and islands on this stream, and they've been both quick, and another framework which is similar, which I haven't talked as much about, Isles, which is it's kind of like Astro but written with Vue templates. They do have a solid integration, by the way, so we'll be checking that out in a future stream. But both of those frameworks ended up using a TurboLink style router as a way to preserve their partial hydration, essentially. So basically, you can send the least amount of JavaScript to the page, and then when you navigate, without doing a full page reload, send an HTML partial, and then partially hydrate that. We talked about partial hydration previously on the stream, and one of the challenges is that once you navigate somewhere else, either you have to reload the whole page because you don't have the code to render that part of the page, or you have to basically load all the JavaScript, which defeats the purpose. This is a nice compromise because well, it's not even a compromise. This is a really nice solution for these because they get to basically go back to the server to re-render. It's kind of like server components. And I think we're going to see more of this. I'm not sure that this will be the final version of this because I think with the way hydration works in Quick, and even Marko 6 coming out, we'll be able to do some even more interesting stuff by being able to hydrate inside out. But it's really cool to kind of see these MPA technologies come here. And it's not surprising, honestly. Turbo is a technology created by the Rails people. They've been doing this for a while. I think one of the more interesting things, obviously, is just keeping it all in JavaScript makes it feel like a little bit more together, a little bit more native. But I think there's still a lot to go on in user experience and the problems to solve. One of the challenges when you do this kind of routing with fragments is how do you handle assets? You already have like the header of the page there. When you navigate, you need to load more CSS and whatnot, and you don't necessarily want to render it into the fragment. You need to have ways to handle different assets. CSS unloading and loading. There's some complexity there. So interested to see what they do and how those experiments go. But as I was suggesting, this drive towards maybe hashtags transitional apps is probably going to start on the MPA side. We have some more work to do on the single page app side, right? Let me see, actually, if I can just pull up one of these demos right now to show you what I'm talking about, actually. Yeah, because where is this? Yeah. They remade the where is it? They remade part of the view docs, I think, with this. Oh no, maybe this isn't the right one. You see, we can take a look here pretty quickly to see if this is doing what I think it should be doing, but I don't think it is. No, that's a full page refresh. Okay, so it's not this one. I thought there was a link in this issue. Blah blah blah. Ha. Is this it? Let's watch here. Let's read more. No, full page refresh. That's interesting. That's not doing what I thought. Maybe the quick one will. I did test the quick one. I didn't look at the IELTS one. The only thing is I think this is actually their official Builder.io site. So they're experimenting on this all the time. So let's see. Yeah, I don't know. That looks like full page refresh to me. Okay, well, maybe they were overselling it. I know, at least they're working on it, which I think is really cool. So we're going to see more of this nature in the future, obviously, because this is kind of where MBAs are likely heading. But on the SPA side, on that note, Evan, you actually posted something. Vue's probably the furthest along on the partial hydration story on the single page apps side, so to speak. Like there's been a lot of partial hydration work going on, especially with islands. Obviously, we've seen Astro and we've seen Quick and IELTS and whatnot, and we've seen like Preact doing a lot of these early experiments even before that. But again, in a multi-page setting, Evan's been kind of playing around with these ideas he's calling like shell hydration, and it's not quite the same thing. You still hydrate the core of the doc in terms of you bring in the client-side router and the framework, but then he's looking at ways of lazy loading parts of the document, and I think that's really interesting. Looking at these numbers, he's still paying a fairly steep hydration cost, like not super steep, but you'll see compared to some of the demos we'll be doing, there's still a pretty big hydration cost here, but not enough to stop getting 100 on Lighthouse. And I think this is interesting. I think this works really well for something like, I forget what he uses, VeetPress or whatever, because it's like basically a doc site with MDX, so it's fairly shallow. So being able to lazy load the specific interactive parts on a docs page that's fairly shallow would work pretty well with this technique. One of the challenges is our single page apps still need to hydrate top down. They still hydrate from root down to leaf. So even if you try and like do some fancy lazy loading stuff, you end up just shelving off the cost. It works well if with a really flat structure, but with nested structure, you basically just take the full brunt a few seconds later. So it's kind of not worth it. Still, this is the furthest we've seen this approach go. So I like that Evan's really starting to explore it. He actually in this this series of tweets actually mentions that like he didn't actually see much of a solution outside of Quick, and some of the thing we're working on with Marko of actually getting out of the fact of this top down nature of rendering makes it really hard to break up hydration when you have a single page app mentality. Everything has to come from the root, and sure, you can break it up with an MPA, but then client side routing becomes difficult, like because there's no single orchestrating piece. So unless you use something like Turbo. So as I said, for a while now, I think we're going to see the separation where we're going to see like very MPA like approaches, and then maybe a little longer in development on the single page apps side. So this is something I'm actively looking into as well, coming up here pretty quick. But I think it's really cool the strides that Evan's already done in this range, and it's clearly working for him. I mean, he went as far as to say, if you can get 100 mobile perf score is a single page app, why reload the page in every navigation? That's a little baity. If you want the maximum performance on that initial load, you're not going to be loading the client-side framework and the router and the libraries. Like MPA still have you there, but for most of us who aren't doing, large e-commerce sites, yeah, and this is true. The smaller your framework gets, if you include techniques like he's working on here and combine them maybe with small frameworks like Svelte or Solid, like maybe pretty good experience all around. It would be interesting. As I said, I don't think every kind of site can leverage this kind of optimization, but that's why we're still looking into it. I actually dumped a huge blog on Solid's GitHub, essentially, on the partial hydration thread. If you do want to check out my current thoughts on that, I'll link that. But it's a bit of a read. I basically was thinking single page app, and this big blob of text here that we're not going to get into today. No, wrong one. Back. I'll just drop this here for anyone who cares. This is my current thinking on partial hydration. All right. So yeah, that was kind of cool technology one. The other conversation that's been happening, and it's been happening a lot, is this idea of framework versus library again. When React came out, that was like the hot topic. Everyone was like building frameworks, JavaScript frameworks, and React is like, no, we're just a library. And some people commented in the last few years, React maybe has moved away from being a library. And I saw that there's this tweet that I saw that's got a little bit of attention this week. That basically was like, back in 2017, Angular is a framework, React is a library, use the library. And then 2021, React is a framework, Solid is a library, use the library. This was kind of a funny comment, but it got people's attention because there is always this this sort of conversation happening between frameworks and libraries. And there was actually a state of the React ecosystem conversation going on, I think back in March. And I mean, this panel here was stacked. I'm just going to pause it here, but it's Tanner Lindsay, who we got here, Guillermo, Lee Robinson, Hunter Miller, David P. Like Blitz, Redwood, Next.js, plus you got, Mark Erickson, Redux, Lindsay Ward. Like you have a whole bunch of big names in the React ecosystem here. And essentially, I asked them this exact same question, and they actually had a really good response. They were talking about we constantly bundle and unbundle things as a way to kind of, make things easier and then redefine the basis, make things easier and redefine the basis. And we've seen this happen over and over again in the evolution of front-end frameworks. And, it happens to varying degrees, right? Even Rich Harris kind of touched on this on his recent chat he had with Vercel. Right? Like it's just kind of funny because like let's see. I don't know if you haven't listened into this one, this one's pretty great. His big thing was like, why would a library not ship with CSS, or why would a JavaScript framework these days not ship with CSS? And actually, I'm going to play a little clip from this if I can.
The React way is kind of a blessing and a curse.
Yeah.
It's a blessing in that it means that you're sort of forced to create these very extensible primitives, and you instead of having like the ability to work on these things locked up inside the team that contributes to the framework itself, like the entire community can solve problems like motion and so on. But at the same time, some things are just really, really hard to do that way. And as a developer using React, like how do you add styles to your app? Like, it's true that you have all of these different options. It's true that by leaving it to the community, we've had a lot of innovation in CSS and JS. But it's also the case that if you're starting a React app today, there is no one answer for this very simple question that every single developer has to answer every single time they build a web app. How do I add CSS to my project?
I mean, he goes on a little further, but I think that kind of captures that question, right? Clearly, Svelte sees themselves more on the framework side. I mean, they see themselves as a language and a compiler and a number of things. But there's this philosophical divide here. And it's one that I kind of got into a bit on our last stream, where I was talking about paradigm versus framework. But it's interesting. Things kind of go on both sides. And this distinction is so subtle. Like, if you look through this thread that I was talking about here, like there's people going, they're all frameworks, or they call themselves frameworks, or they call themselves a library, or where someone made this same thing back joke about React calling themselves a library and whatnot. Honestly, I usually don't try and get into that debate. It's too nuanced, but I do think that the driving philosophy is better than the definition. It's not about like setting some criteria on what makes something a framework or library. It's about the philosophy deriving the design from that, right? And like a similar thing is, like, I would definitely consider Remix more on the framework side of things. It's a meta framework, in fact, built on top of React. But Kent C. Dodds was actually going, he kind of did this nice little thread here where he was saying, well, there's something, awesome about, wow, look what I can build in 10 minutes. But often that's followed by several months of, this is really hard to change and customize for my ever-changing use cases. And that's part of the conflict, right? When you make things necessarily easy for the sake of easiest, not necessarily adaptable. And he goes, well, yeah, Remix obviously strives for both speed and getting started in long-term changeability. But we prioritize the simplicity and changeability first. That's why we limit the magic and expose you directly to the platform. And I love this part here. He goes, I immediately knew we were onto something huge. It was because they were nailing a solid foundation of primitives. Once you get that foundation of primitives right, then the things that you can build on top of it are really powerful. And that's the message, right? It's all about, if you believe on the, like the library side versus the framework side, it's all about building up those primitives, right? That's the basis of what we do with Solid even, how many times do we use the word primitives on our homepage? It's essentially this idea. And I think I'm going to do a stream in the future where I actually really emphasize and get down into that. That was like a close tie to what I wanted to cover this week. But honestly, streaming is timely now, and we'll probably come back to this topic. But I think this library versus framework thing is going to be a continuing conversation, especially as React enters like this phase. It's already happened. React is in that framework, bundle phase. And once the key player enters that phase and things just kind of grow that way, there's going to be new players that unbundle. It's inevitable. And obviously Solid is one of those. But even, some of the work in these MPA frameworks might classify into that, right? Changing the foundations, looking at the primitives again. And I think it's interesting how you can even do this, in a, smaller way, like say in the way that Remix is built on top of React. They can still kind of take things back to the primitives in a different way. So I think I'm definitely on this side. Mostly Solid was built out of me working at a startup, maintaining the same app for almost a decade. That experience of looking at how things change over time was the thing. Like, I know a lot of people like talk about, you can tell Svelte was built in a newsroom. They make new apps every week or so, and then they start again, and they got to get quick on, make something, get it out there, give it, all the nice jazz and ship it. It's a different game when I working on a startup where we were under-resourced, underfunded, and one of those maybe startup for life companies, unfortunately, and essentially we didn't get to do completely greenfield. We never got to build new stuff. We had to build on what we already had, but there's always a need for new features, always the need to adapt. And for that reason, I value primitives above almost all else. But as I said, I'm going to cover that in another stream. I just thought this was an interesting conversation that's going on right now, and it's kind of meta to what's been like the whole bigger picture of how the different players fit in the ecosystem. So I'm going to take a stop here for a second before we move on to streaming and take a look at what's been going on in chat, because I've been just talking my head off. What do we got on here? All right, what do we got here? I got downvoted a bunch on Reddit for saying React is a framework. Somebody said, add me to LinkedIn so I can avoid you. It's funny how people get angry about this. Maybe it's the philosophical thing, but it's like React is treading on framework water these days. And it's not necessarily because they're trying to do concurrent mode and suspense or something, although I think that was one of the responses in here to this, because I wrote something along the line of like, I love the thinking, and then Michael, I forget, someone said that. Yeah, I forget it, but like essentially that React is getting more framework-like, and I don't know. It's probably not worth getting into those arguments. It's yeah. This was the earliest definition of a framework versus a library, and there's I get, you know what? Every reactive library is a framework then, right? Because like the whole idea is with the reactive libraries, you set the rules, but it calls that code. I know that's why, like, and since most UI programming is reactive, like maybe we're all frameworks, right? This is the definition though that I was always taught, and this is the definition that we like. I think this goes back to like C days. Yeah, primitive love. There's that great. I'd probably have to go down in my feed, but there's that really great AWS talk that Brian LaRue. Yeah. Look at this one. Isn't that awesome? I'd love to be on a stage that big and have that behind me. Yeah. No, I've been talking to them. We'll see what we can do. I think there's potential here, and Jacob does too. So we'll see what we can do. Generally speaking, my experience is framework agnostic solutions are very difficult, and they only work if there's complete isolation, which you can get with something like Astro, which has islands. But when you try to do smarter things to pull it together, like client-side routing, it becomes really, really hard. So we'll see. Yeah. I saw this. I have to admit, I think that's stretching it a little bit. I mean, if they want to go that way, they can. The use in front could be used as a compiler hint. It's basically the same thing that I was talking about in my last stream, where I was saying like a function decorator, like Vue refsugar does $, and Marko their tags, but essentially function wrappers is an easy way give the compiler a knowledge of composable cross-file reactivity. So they could use as a mechanism for it. But I mean, if React can take that flag too. I think the challenge is I'd rather it be more clear-cut, right? It's interesting. I mean, Vue is trying to be everything to everyone. Svelte is like very clearly on the one side now. React was always clearly on the other side. Are they losing their identity when making phrases like this? Maybe that's their long-term vision. Maybe this is all like a migration strategy. Maybe hooks and everything was a migration strategy to go from one point to the other. I mean, there is some truth to the fact that certain problems are much easier to solve compilation if you have the right tools, right? Especially if you want to minimize JavaScript. It's really hard for the end user to be able to hand optimize that. So there is value there, but I'm wondering if this is intentionally laying the groundwork for a change, because React historically is not a language. So I mean, I have considered how you could apply a compiler analysis and I'm pretty sure the use of use was intentional for this as a way out, but I think there's a lot of ways this can still go. Thank you. Yeah, I mean that I don't think maybe that it's not a real definition. Like maybe the framework library distinction doesn't matter, like the names you gave them, but maybe it's just like the philosophy is the important part. Yeah, this is awesome. Yeah, I mean, and I guess that's the way that I talk about reactivity, to be fair. Kind of just jumping back to the Dan conversation. But there are, as I mentioned, there are three kind of primitives to it. I mean, I guess the language similarities come in the fact that is if you hooks let React focus on primitives, and when you focus on primitives and you try and keep the minimal set, it is very similar to the tokens you could like find in a language, I suppose. But I think the option to compose and build makes that trickier, because like there's a difference between having defined syntax and having conventions. So I mean, conventions are fine, they become like a new syntax, I guess, but it's like Svelte claimed to be a language kind of in the same way. So I mean, it's interesting. If React really does want to become a language, yeah, actually no, I'll hold off on that thought, because like I think that the thing is like these are kind of very grandiose ideas, but it's weird because they're limited to the scope of their components or the things, and this true is felt too, like the things that are very part of the framework. It's not universalized, and that's sort of why I was looking at stuff like Reactive or whatever, like in that blog post, because it is still very much a library, so to speak. Like it doesn't escape the boundaries, and I wonder if it maybe it doesn't need to. So but maybe this framing helps people kind of better understand it. You know, yeah, always. I enjoy doing this. Yeah, a lot of different opinions here on frameworks versus libraries. Yeah, it's interesting though. Like React historically was always like about best practices, so you know, and those patterns change. So I don't know. We could talk about this forever, and maybe the next stream or whatever, when we do get into this a bit more on the solid side, we will. But it's this is just a wide open topic and can of worms, and we probably should move on. Oh, this. This is a good tie-in though. I major props to our community member, Joe Pia, True Skater. He just had he's been having some friction with TypeScript, because almost everything in TypeScript was made for React, and VS Code, and everywhere you go, everything like JSX related is like clearly React. Right? Like and basically he was like he's telling them VS Code, he's like, can you change it from TypeScript React to TypeScript to JSX? And honestly, if you haven't been here, maybe do so. Give this thing an upvote. It doesn't really need any more. It's almost at 200, but why not? He's just saying like there's a lot of frameworks that use JSX. Obviously, like the React clones, the Preacts and the Infernos and whatnot, that are becoming less React clones as the days go by. But you know, things like Stencil, Solid, you know, others. Maybe it's time to move on from JSX or TSX just being a React thing. but yeah, he was immediately met with a little bit of pushback. But it seems like this is a fairly popular idea. Other than you could tell an idea is doing well when there's like the 1 or 2 people downvoting it. That tells you that you're doing a good thing. If no one downvoted it, then not enough people have seen this. So, it's a good sign. This must be a good idea. Okay. Yeah. So, yeah, it's funny tie into the language thing. Yeah. I mean, this is true and this is painful. React JSX pollutes the global namespace. Most other libraries don't. Most other libraries now actually like use import source and have a mechanism. But basically, if you just put JSX somewhere, it reacts around, like React will take it. So it's really a pain. Yeah, I feel that pain. Definitely struggled with that in the past. We were polluting the namespace before too, and it was a mess. Luckily, the one good thing that came out of the new React compilation that came with the React 17 and the new JSX transform was that they got rid of the pragmas in the files, which means suddenly you didn't need that, and you had a different way to denote the import source, which finally worked for Solid, because Solid doesn't actually have a factory function. So until React made that change, we made issues and stuff, but we were largely ignored. People like the other ones use factory functions. So pretty happy with when the progression kind of goes in your favor, even unintentionally. Sorry, I just said the. Yeah, there we go. I'm not going to get started on the topic of testing and right types of tests. We could also be here forever. So let's turn this around. What else are we talking about? What is streaming? Let's get to the topic at hand. We've been going now for 36 minutes. I think everyone is here. Let's talk about streaming. Well, streaming is probably a really poor name for something that's been around forever. Streaming started, basically, streaming is also known as HTTP chunked encoding. It's basically the ability to send the HTML back to the browser in pieces. Like, instead of just like making a big thing and just sending it all at once, we can control sending it back in pieces or parts. And basically, all HTML has the ability to be streamed. But when we're talking about streaming, we're talking about techniques that leverage the fact. And the thing is, browsers are smart or resilient, or I forget what the term is. But essentially, when you send back your response, it gets the HTTP headers first, and then it starts rendering the HTML tag and the doc type and the head and then the body. It can start working and rendering those pieces even before it gets all the closing tags. You don't need to close the HTML XML tag or whatever before it can start rendering. And that's really cool and something you can leverage. And you can tell that the platform was built initially with streaming in mind. Then somewhere along the way, we just stopped using it or leveraging it. Some backend services used it through, as I said, it was 97. I think that chunked encoding became a thing, but they used it, through late 90s, early 2000s. I remember there are things like dial-up modems. Getting things in piecewise actually made a big difference. And then it kind of disappeared. And the funniest thing is, if you go searching for it, it's pretty funny, because you might come across streaming because of, say, React 18, right? And that's kind of publicized it. We also have the same feature in Solid, but let me see if I can find it. Just a second here. Bookmarks. I might have to go down a little bit. But essentially, this tweet from Dan kind of things. So you're looking at React and look at streaming, and then at one point I showed him this, and he goes, I haven't looked closely at Marko, but this 2014 article describes a mechanism that's ahead of what most mainstream solutions, including React, do in 2020. We've been trying to add this to React since 2018, but it's peculiar how this is almost a lost art. So we have React working on this feature for, like, to give you kind of connotation, suspense is the streaming feature. Suspense does a lot of other stuff, but suspense is essentially the streaming feature. The reason we've been waiting for suspense is because of streaming, largely. I did cover that in an article I wrote this week, and where I talk a little bit about, you know, what suspense is. But essentially, if you go looking, you're like, okay, so streaming did not show up in React 2021, you know, out of nowhere. They started working in 2018, and if we go back another 4 years, Marko had it. So we can look here, and in this, we're talking all about streaming. And already, the Marko guys in 2014 are talking how they're rediscovering streaming HTML. In 2014, they're rediscovering it, because the truth of the matter is, there was an article called "The Lost Art of Streaming" back in 2005. If you go back, basically every decade we decided that we've essentially forgotten about streaming. It's been like 30 years now or something, and or I guess not that long. It's been like 25 years almost, and like every 5 years we realize that we've forgotten about streaming. I find it hilarious that in 2005 it was a lost art, and it was rediscovered in 2014 and rediscovered in 2018. And I'll get a bit more into this, but essentially, probably the biggest usage of streaming, and that kind of got popularized it in more modern age, and this is, I'm saying modern, but this is back in 2008 or 2009, was Facebook. Facebook had an architecture called BigPipe, and BigPipe was their PHP service, but it allowed them to kind of weave together all their assets, CSS, HTML, and serve them, you know, performantly by kind of streaming all the different pieces in. Yeah, no, I was going there. I realized as I was speaking that I sounded like an Eminem song. Anyway, but essentially, Facebook had solved this, you know, and it was in PHP, but they had a really good foundation. And when eBay came around to be like, oh, we need this too when we design our new web foundations, but we're going to build it on JavaScript this time. So, you know, and eBay built Marko. It's kind of started back in 2012. They're like, okay, we need to send the least amount of JavaScript, we need partial hydration, and we need streaming. Streaming is super, super important right from the beginning. And that's because eBay is a company that values page loads, because when you have SEO concerns like loading content from you know, search results. Let's say someone does a Google search and they see some, I don't know, some item of desire, and they click on it to go to your page. It better not take forever, and especially if it's a slower device and whatnot, you're going to lose sales that way. And it is a measured thing. Like we have departments at eBay that basically are anal to the points of hundreds of milliseconds and correlating that to sales losses. So, you know, I had a great talk on Theo's stream with Dan, and we were talking about how the metrics you use sometimes aren't related directly to performance, but sometimes they provide different use. In Dan's case, they were losing like counts. So in eBay's case, it's like, are people buying? It can be misleading, obviously, but it essentially, those metrics drove Marko there. React didn't go through like Facebook didn't do a big rewrite to, like, they had React in lots of places, but I believe they didn't do like the big React rewrite until 2018 time period. So is there a coincidence that Facebook and React got into streaming around that time period? I think not. I think suddenly you know, performance at a large scale became a concern. I still love Sunil, who's the former React core team member, made some whole thing. Is like, oh, React doesn't give a f about about SEO. That's not why they did it. And it was all about developer experience and kind of streamlining stuff at Meta, which I thought was funny because, in terms of talking about why server components, they started working on the streaming thing. But it is interesting though. Streaming, in my opinion, has the potential, especially for large sites, to be one of the biggest game changers in terms of performance. And we haven't, especially for single page apps, which haven't got the leverage. It's big on multiple page apps too, because you get to keep on sending HTML even after the fact, which means you can still partially hydrate stuff you stream in later. Always. Well, I mean, he's the one who said it was funny. Matthew Phillips, I didn't search the tweet, I'm not going to search it up right now, but Matthew Phillips said in January 2021, he was like, 2020, this year is the year of partial hydration. And in a sense, he wasn't wrong, right? I mean, maybe there's more to go there, but Astro made a big splash and quick, and a lot of new tech showed off what we could do with that. And Sunil, not that long ago, I retweeted it. It was actually funny. JetBrains guys said it was their tweet of the month, actually. But I don't really need to search it up. But he basically said that next year is going to be the year of streaming, and that everyone should get prepared for it because yeah, here it is. 2022 is the year of streaming responses, hence streaming APIs, which means clients, your actual super agent, even plain fetch will have to be rethought for that use case. Take note. I actually don't know how to do any of that stuff, but looks like I can. There we go. Done. Thank you. Okay. We can talk about streaming setups, different type of streaming setup at a different time. I think you could help me a lot, Theo. Okay, so moving on here. Streaming's a big deal, but what is it? Okay, I've clearly got the history going here. It's a long time coming, but the basic of it is hopefully simpler than this explanation is giving here. This is why I got a scala draw. Let's do some drawing, okay? I mean, it's not hard to picture sending your HTML document in pieces. That's kind of uninteresting, right? I mean, consider. Let's just draw a page to consider. Our scenario, and then we'll kind of get back to it. Right? Like, let's consider a page, and let's say our page has a top nav. Let's even say our page has a side nav. And I use this page all the time. You guys have seen this page before. Here's our page, right? Where technically, like, there's maybe a hero image and then some content. And the thing is, if you were to lay this out as HTML, for the most part, I imagine the layout would something be like one. Not that. Actually, maybe it's easier just to draw it. 2. No, never mind. I suck at drawing. I'm going to type 2, 3, 4. Like, even though there's like a layout, generally it might flow out like this, right? And the thing is, for this top nav, you probably don't need to load very much information. You may need to load information for part 2, but you most definitely need to load information for 3 and 4. And 3 and 4 might need separate, different information, right? You can see this in any kind of real site. I mean, we're looking at it like profile page on Twitter. I mean, I shrunk it down, but there's nav and the header and tab bar and content. You've kind of seen this before. Now, the problem is, and this is common in most frameworks and solutions, is you just wait for the whole thing to render and then you send it. But that doesn't help you that much if you want to get assets earlier, because you have to, the process of loading a page in a browser involves, well, I mean, again, we've all seen it, but involves, the header section of your page. You have like all the link tags and the JavaScript and all that stuff that's a load. And if you're not sending the page, you're not requesting that JavaScript. You're setting the whole thing back. So streaming immediately gets you that benefit. But you know what? Marko probably has the easiest way to show this. I don't know if you've ever seen this. This little demo thing Michael put together, I think is a lovely example of what the difference between async and streaming rendering, essentially. And I'm going to use this example here because it kind of highlights it. He's not doing, well, I guess he is doing out of order streaming here, but he's not showing placeholders or anything. But if you look at the way the one on the right loads, you should notice something. The header comes in first, right? And then he's able to load this content. And while he's loading that content, the image loads in. And while that image is loading in, he's still waiting on, the comments and stuff coming in. So this is kind of a streamed page experience, right? Even though it's all server rendered, not client rendered, you basically you could have loading states and stuff coming in here. Now, with an async render, in theory, it should finish at the same time, but it doesn't. If you look at here, this is showing stuff sooner, but when it's all done and the last bit of data comes in and this one draws, it's still waiting for the image because it didn't get to load the image sooner. Because you were streaming, you were able to tell the browser to get that image sooner and load it in. But on this page, it has to wait for everything. So it's not only that the first paint happens sooner, it's not only that you get to see stuff sooner, the whole page loads faster thanks to it. And that's essentially, this visual, I think, helps explain this a lot. But the reason I wanted to pull out Excalidraw is we aren't really talking too much about how this happens, right? Because in Michael's images, he didn't put any placeholders. The truth of the matter is you can put placeholders in here if you want. You could say, essentially, draw initially the nav, and then essentially, let's put a green and give it a stroke, maybe. And then draw, some loading stuff over here, right? And you've got maybe some loading placeholders. And then essentially, when this loading placeholder gets lifted off, maybe this still hasn't loaded. So you have a loading placeholder here, and then finally it loads in. Or depending on how you set it up, maybe you want this whole section to have the loading indicator, and then you'll wait a little bit extra long, and then when you remove it, the whole thing appears. There's different ways you can break this down, but the thing is, with streaming, you can serve the initial results and then replace it in place. Can you manually prioritize? It depends, right? It depends on the mechanism on the server, right? Because the server is just trying to spit out HTML strings as fast as it can, right? Generally speaking, you would just serve everything as fast as you can. Like, we're not streaming because rendering is taking too long, generally. We're streaming because there's blockages in I/O, that there's how should I put it, that there's like you're waiting on some data. So it's less hydration is a prioritization question, and we'll get into that. But streaming rendering itself is less so a prioritization question. It's more of just like do as much as possible as soon as you possibly could do it. It is possible, and I've seen this in some of the more advanced React threads, that they can prioritize pieces in case certain pieces want to start rendering and like multiple of them have queued up, and then they can like make the choice and be like, oh, is it my turn yet? So I think the answer is yes. And React is looking into that, and maybe that's something that's important, at their scale. With Marko, we don't prioritize. We just split everything into its own separate thread or task or whatever the term is in JavaScript. And essentially, we just fork at that point, and the main reality continues on, and the side reality does it. So we just parallelize everything. Marko solution is really quite cool. With Solid, I haven't done that. I haven't looked at that yet, but it is a consideration if you have lots of these coming in. I think you can make async finish and yeah, I mean, there's different ways to coordinate that, right? And your timing for flushing depends more. Like you can choose to go, I want to send all this at the same time or not send this at the same time, because once you send it, then the browser has to do work. But generally speaking, at least for anything relatively mid-size, that's probably not going to be your blocker. Rendering is fast, like really fast. Like I've mentioned it before, I got some benchmarks that show that's like Solid's very, very fast rendering, maybe 10 times faster than React. But in practice, like no one cares except for the people doing the metering on your serverless functions. That's not what's going to do it. If the page is big enough and there's enough stuff, maybe, but generally it's going to be it's the IO stuff. HTML early flushing. I mean, that is what streaming is. If I wasn't clear, it's just chunked encoding. So like if you're using Express or Node or whatever, you might have seen like res.write and versus res.send. When you call res.send, it sends the headers and does everything. So if you're doing like a typical response in Node, you'll do a bunch of stuff and then you go res.send at the end, and then it knows to send everything. Whereas in res.write just sends a bit of it out. And at that point, the first time you call write, Node will send out your headers at that point. And then it'll just continue from there until you call res.end yourself. You can't call send on a stream, essentially. But all streaming is just sending HTML in pieces. It's not like some new WebSocket technology or something fancy. It is just HTML HTTP chunked encoding. It's like just standard stuff that's been built in the platform for 25 years or whatever. What I'm getting at is you have these placeholders, essentially, is the common thing. Marko actually has a version of streaming, and we actually use it at eBay a fair bit for top level things, which is called in-order streaming, where essentially, even though it'll fork the processes and do stuff, if 3 finishes before 2, it will wait for 2, or if 4 finishes before 3, it'll wait for 3 to flush it. And the reason in-order streaming actually does layer the document from top to bottom. The one benefit of that approach is it requires 0 JavaScript. Like absolutely 0 JavaScript. So it works even with like bots that can't run JavaScript. Out of order streaming, like you find in React and Solid and Marko with these placeholders, does require JavaScript, but it doesn't require the main bundle. It doesn't require very much JavaScript, but you need JavaScript to move stuff, because the way this works is let's pretend that 3 and 4 have data in our case. And let's look at let's now, instead of this, look at our HTML document. Okay, let's rethink this as an HTML document. So this is our document kind of coming in, right? Our first bit here is going to be our synchronous chunk, right? So we're going to send one, and this is the pretend this is the HTML, right? We're going to send one, and we're going to send two, and I'll put the numbers on it. Actually, you know what? To make this demo better, I'm going to change this example slightly. We're going to have a footer too. This will just make it easier for me to illustrate. And the footer, technically, I don't feel like the footer, I'm going to give it its own number too, but unfortunately I have to move all the numbers down. The footer really should be, the footer really should be, sorry, what did I just do? Like moved everything. This is my awesome lack of Scaladraw skills. Okay, nope. I don't think I got everything still. Oh, there we go. Thank God. The footer should get a new number here. So let's give it, let's make the footer 3 and then update these appropriately. 4 and 5. So what this is going to do essentially is, and this is actually probably, I should actually edit this example just a tiny bit more, because in reality, the way this works, and you're probably familiar with this, is 4 actually wraps 5. It's pretty standard for 4 to wrap 5. Like it's the page in the page, like it's usually more like this, right? So 1, 2, 3, 4 that wraps 5. That's the more standard setup here. And essentially, what it will do, sorry, is we'll make like make one more here. On the initial flush, here, what we're going to do is we're going to render 1. So weird that it resized. I have no clue why I decided to resize like that, but whatever. And again, 2. Sorry, this is messing with everything. Clearly not an Excalibur wizard. Maybe I have to draw a box. 1, 2, there we go. 3, and we're going to render 4 placeholder. Okay, that's essentially what happens on that initial render. Okay, so it renders 1, 2, 4 placeholder 3. So you actually render the footer in place. Then when 4 finishes, I'm going to assume that 4 finishes before 5. This is not always the case, but when 4 finishes, it just appends it below the footer here. Maybe in a hidden field or something, but it appends it below the footer. And then we'll give this 4. And then it'll also flush with it a small script tag, essentially. And that script tag will tell it to insert 4 where 4p is. So it'll actually do it. But in the case of 4 as well, we also have inside of 4, sorry, we have, I'm going to change the color of this one again. Set of 4, we have five placeholder as well. And this is also that later when 5 loads in, 5 does the same thing again. 5 gets rendered on the bottom with its own script tag. Sorry, 5. And then with its own script tag that we're going to stick here. Okay. So this is essentially our setup, and let me just put the number 5 in here. Cool. Okay. So you get this kind of weird onioning going on, right? So essentially, we first draw 1, 2, 4 placeholder 3. Then when it finishes later, we draw 4 with the placeholder for 5 in it and our script tag. It runs that script tag, which inserts it. So at that point, we've actually moved this up to here, right? So now you'll see 4 in place, right? This doesn't, the framework might have not even loaded at this point. You might be still waiting. Hydration may or may not have started at this point. And yeah, X, let's change this arrow. This arrow is the blue arrow, right? And then when 5 changes sometime later, this is up here, and now 5 inserts into there, essentially. So we have this kind of, I don't know what it's called, it's like those like Russian dolls or whatever going on. Essentially, that it just inserts into each other using script tags that get flushed synchronously. That's the trick. It does require JavaScript, but it does not require the main bundle. It does not require, it doesn't require very much, in fact, to do this. And the hard part for coordinating is while this is happening, you're loading other assets. You're loading your CSS. You're loading you're loading your JavaScript. So it might start actually hydrating. That's the whole key here. If you wait until the end, like document ready, or which is the default. I don't know if you all are aware, but by default, scripts tags don't execute for type module until the document, right before the document load event. If you wait till the end, you're not hydrating or doing any work until this all finishes. But if you have the ability to use the async descriptor on the script tag, it will start loading as soon as possible. So that means that this whole process, while it's sort of outside of the framework has to be aware of the different states in order to handle it. So I'm going to show a quick demo now of what this actually looks like. Essentially, let's see here. Do I have a banner for that? No, we're still here. Okay. So essentially, I've written an app, and I've used this example before. Don't worry, I'm gonna blow up my screen so you guys can all see it here. Let's see here. Here, this is in the solid repo. Right in the SSR examples, I actually have different versions of the same app. The app, I've used this app before on previous streams, but essentially the gist of this whole thing is we have a simple app. It has a home page, a settings panel, and a profile. And the profile basically does a little bit of data loading. It's kind of a mess, but I've made a couple resources that are cascading. And then the profile essentially shows the information based off the first thing, and then uses a suspense boundary for the second one. And that's the whole thing. So if you've been looking at all this data loading stuff when I showed the placeholders and thought this looked like suspense, well, as I said before, it's because it is like suspense. Essentially, what we've done here is our index route is wrapped in the suspense. This is our quick makeshift router. And our page has a second suspense that relies on the cascading data. So this having two suspense boundaries lets us not wait for the whole thing, but do it in chunks as it comes in, which is helpful for the choice of this demo. And essentially, if I can run this one, let's build it first, just in case. Build example stream, just in case it's out of date, and then okay. I'm going to open this one up, local ADB. Okay, so this is a simple demo where we have our pages navigating, right? And there's just some stuff on it, just garbage. This one's a counter. The reason I have the counter is to show concurrent rendering, because when you go to profile, it's still rendering the counter while it's rendering this off page. And the reason it takes so long to load is because this is our cascading data. This is what we're going to be looking at. When we refresh the page, you can see John loading John's profile, and then we load the second section. This is 400 milliseconds cascading. It's kind of a lot, but I just want to do this because it's easier when you have data latency to show off streaming. So fairly simple example, load. Now, what does this look like is kind of the interesting thing. In a simple app, where this is client rendered, you would expect to see requests happening in the client, and it would use suspense and look very similar. In fact, I do have that demo here, and maybe that's the easiest thing. Although you actually see here, because the console logs, this is loading on the server. But let's very quickly show, before we show the streaming, let's actually show what the Jamstack version of this is. This is essentially rendering a synchronous shell, and then all suspense and data loading happens in the browser. In fact, sorry, let's refresh. It looks almost identical to what we just did, right? And if you look here, I'm actually going to move this off to another window because I have browser extensions that are a pain. But if you look here, what's going on, we just have a head tag. Solid has this little thing for hydration called hydration script, which does cool stuff like event playback and some other stuff, support streaming and all the other hydration stuff. But other than that, it is just our app with our suspense, and it just loads in. There's nothing else to this page. We just reload, bang. Now, if you were using something like, not this one, if you're using something like Next.js or Gatsby, you might, or StealthKit or something, you might be used to the next mode that I'm gonna show really quickly here, just to kind of explain this. I'm building up the streaming because I think it's important to sort of see the difference and how it kind of progresses from one to the other. I have shown this a little bit before, but I think it is kind of illustrative. This is your typical, the first app I showed you was Jamstack. Pre-rendered shell, essentially. It could be SSG'd, it could be on demand, but then it does like the requests in the browser. And if we looked at the console here, you see the load user, load info, and it as it cascades in. The Jamstack, or sorry, the more typical like Next.js or StealthKit page is more like this. And as you saw, there's no loading here, right? It is reloading. You can see the counter reset, but you don't see the loading because the page comes in fully rendered, like over the network. If we look at this, let me format that and shrink this window. What we get is our hydration script and then our fully formulated HTML. And the key part here is we write that data into the browser, right? Here's the Jon Snow, and here is the list. Basically, we serialize the data into the head, and we render the full thing. And I mean, this example is a little bit trickier than I think some of those frameworks support, mostly that this is lazy loading components, right? So Solid, it does support lazy loaded hydration, which is already a little bit complicated because it means that not all the JavaScript is necessarily there when we go to hydrate. So we actually have to pause and resume hydration as the JavaScript loads in. But the important part here is you never notice a loading state because it waits for it all. And we'll see the implications of that in a minute. But I just wanted to kind of show how this builds up, because our first page, we didn't send the data. And as you see here on the console, there's no logs here. As you'll see, we're doing all the work on the server. Streaming, and here's the data being written into the head right here. Streaming is basically the kind of combination of in the middle. Build stream, or I already did build the stream. We'll build the stream again, and we'll start the stream. So the streaming example is that it looks a lot like the client case, but we have slightly different HTML. And I'm going to go back to the network tab here because it's easier to see it in its original form than it is to see it in the final form. The final form is exactly what you expect, but in its original form is a little bit more interesting. So we have our hydration scripts, and then we flush out all these initialized things. And I need to do this to basically tell the browser that, hey, you're going to wait on this information that's going to be coming. These are our unique hydration keys. They're not the prettiest things, but they gzip pretty well. But essentially, when we render the page, we render our nav, see, home, profile settings, and then we render our tab component, and bang, placeholder, loading spinner in the span. And then we finish our body, render the rest of the page, render our async script tag into the page, and there, the HTML closes. It's over. Well, no, it's not. When the first async request finishes, we actually send it along the stream, the data. We create a hidden div where we put in the content here of the panel, the John's profile, where we server rendered it. And then the section could be about you. And we actually render in this other spinner. It's exactly what I showed in Excalidraw a minute ago, right? We have another placeholder, see the PL at the front, for this one. And then we flash the script, and this very simple script here just replaces the nodes. It finds the element with the ID and replaces it with the child nodes, and then it triggers the suspense to say, hey, you can continue hydrating now. Behind the scenes, our hydration script basically uses promise resolution, where the server basically when we call init, it sets up these inits. It sets up a promise that if hydration gets to it first, it reads the promise. And when we set the data, it resolves the promise, which lets the client continue where it left off, if it's fast. And if it's fast, it's like this. You get to see that loading state. It feels like client-side rendering. But if the JavaScript bundle hasn't loaded, it's still going to behave like this on the HTML. It just won't hydrate, and the data will be available right away. And then, so we define our function, and then we call it. Then we also initialize another suspense boundary, right? The second one. Now some time passes again, and the second data chunk comes in, flushes the rest of the page, and then inserts into place, kind of finishing up the hydration story. So this is exactly pretty much what I was showing in our Excalidraw here, where we have two cascading ones, right? A lot of cases it's simpler, there's a single one, but I wanted to kind of show how we do the insert and the insert, kind of chain up. What's really interesting though about streaming is, yeah, on a fast network, this feels fast and you get this loading state. But on a slow network, I just went to fast 3G. Look what happens. You don't see any loading state. And the reason for this is there's no delay. By the time that it serves it, all the HTML's here. And that's a huge difference. When you do client rendering, you always have to render that loading state because the client has to render it, right? If the main bundle hasn't run or you don't have the data, you have to do it. But with streaming, because it's separate from that, it scales with the network. If you have a slow network, it looks just like normal async. If you have a fast network, it looks like client. And the results are actually really cool here, because let's take a moment before I got some better examples I want to show, but let's take a moment here and kind of look at the performance profile of this stuff, just to understand. As I said, this is a pretty contrived example, but what's nice about it is it's steady. These are exactly 400 millisecond delays. So we can see a fairly consistent result across the different approaches in terms of how performance changes on fast and slow networks. And I think that would be interesting to kind of get an idea of the benefits of streaming versus other approaches. So let's set it up. We've set the stage, right? There is a fourth mode in my demo, which is SSG, and SSG is just unfair because it has perfect knowledge, because it fetched and pre-rendered it once. Obviously, nothing beats SSG, but it does give us a baseline. So maybe that's where we'll start here, and we'll take a look and kind of understand that. So I'm going to build the SSG example. But if you see load user, load info, this SSG is basic. It's all about when you do the queries. SSG does the queries at build time. Our async and streaming SSR do the queries on the server, and our shell approach does the queries on the client. That's basically the difference between the approaches. So obviously, as a baseline, our SSG example is can't be beat. But we'll just run our SSG example, okay? So let's just do this, and we're gonna take most of the window up here. We're gonna do a little bit of performance profiling here. Okay. So I'm gonna give it a quick reboot. You can't see SSG. You can't even see the load. So I'm gonna start profiling. Okay. So this is about as fast as things can possibly get because it's all pre-rendered. Okay, including the data fetch. So on my system here, while I'm streaming with you guys, we get a first paint of about 39 milliseconds, and the full paint at 39 milliseconds, and the first contentful paint, and then the largest contentful paint, which is basically around the time the header comes in. This isn't when it's finished. For this example, it thinks this is the largest contentful paint. It's also at the 39, unsurprisingly. They all come at the same time because it's pre-rendered on the server. And then the onload event happens at about 54 milliseconds, and essentially, yeah, we're all done around the 54 millisecond mark. Nothing beats SSG, but let's now run SSG on our fast 3G network. I love that they call this one fast, and we'll use that for comparison. Okay, I think it's still done. Okay, on our fast 3G network, things are significantly slower, but SSG comes in at about 1154 milliseconds, and everything comes at the same time. And you notice here that this takes a little bit longer, and essentially, I guess hydration here is done at 1798. Okay. That's interesting. This example doesn't have preloading, so this might not be the best example for hydration time, but it's good to show off rendering time at least. Okay, so let's move on, and let's build our. Let's do async next, or no, let's do SSR next, which is our. Actually, we've already built these all. Let's just go straight to the comparison. So let's refresh the page once. Okay, so I'm going to go back to no throttling, refresh. And we'll run the performance comparison. Okay. No throttling. We have a first contentful paint at 25 milliseconds. So this one was really fast, actually. There's going to be some variety between our runs, but largest contentful paint comes much later because it's at 4:37 because it has to wait for the first request to happen. And we're actually not all done because I told you there's two 400 millisecond requests. We're not all done until about over here, about 8:50, essentially. So essentially, there's a slow, it paints right away, but then there's like there's a slight overhead. It's basically offset the whole thing. Like that 25 becomes 37 and becomes 50. There's a slight bit of offset, but essentially you're just seeing the length of the requests here. Now, if we add fast 3G throttling, the story gets a little bit different with client-side rendering. Okay. Sorry, I didn't hit this. Okay. Loading. Okay, perfect. It's the same about 1170 for initial load, but essentially now our largest contentful paint has moved to 2000 milliseconds because of the speed of the network. It's taken longer than the data request to actually draw it. And by the time we're done and hydrated, we are actually sitting at about 2.43 milliseconds, essentially. Now I'm going to do async next. Back to throttling, refresh once. Okay. Right. With no throttling, async waits the whole 800 milliseconds before it sends anything back to the page. This one, that means first paint doesn't happen to 8:35, and then it's not done till about 8:46. So, I mean, obviously the first paint deficit isn't good, but even more than that, it's taken that much longer to kind of finish up. And let's do, slow 3G. However, when we have a slow network and we run this again with the async, first paint comes in. Ooh, that wasn't a good run. Sorry, let's run it one more time. Oh, maybe it's realistic here. Okay, first paint's coming in at 14, and then it's finishing also hydration around 22. Okay. And let's finally do streaming. I think one of the interesting things about doing this live on stream, I realize, is that the network conditions are different when I'm streaming, live streaming, than when I'm running it locally, which without streaming, which might be affecting the results here a little bit, which is unfortunate. Let's run streaming one more time. Let's run streaming. First thing you're going to notice on the fast network with streaming is 27 in, 418, and 817. It's even in this silly example here, the streaming example is faster than all the other ones at every single. It's the same first paint as client side because it doesn't have to wait to do anything, or sort of like shell rendering. But every other marker, it's faster because it gets to preload stuff. And when we run it with network throttling, it's funny, again, you don't see the reload in this case. It basically performs, see, it came in faster than async at 1194. And it hydrated at 2 seconds. So This one isn't good because we're not preloading the profile. It's not loading till this point, which is unfortunate. But again, streaming beat all the other mechanisms, even without preloading the profile properly here. Simply from the fact that it got to load stuff sooner at every point. The interesting thing is, as this digresses, the client-side rendering and the streaming, which were very beneficial on the faster network situations, the client side gets much worse because it takes that much longer to do real async requests, and that's the thing that we're missing in this comparison, because these are simulated. Okay, I know that was a bit dry, but I wanted to take a moment to kind of show the different characteristics. Obviously, I care a lot about benchmarking more than other people, but essentially, you know, I do also have examples where you could do the same thing with preloading and more variable data, but essentially, streaming kind of has the ability to improve performance at every point. This is a nothing app. When you consider the fact that there's basically nothing here, like it's no surprise. It's surprising that you can even notice the difference between these, even up to a couple milliseconds on kind of like a kind of crappy network. Anyways, that is most of it. Let's see. I'm going to switch back to chat and see if there's any questions here. Yeah. I think that pretty much. I think that pretty much is the thing, because this is dictated essentially by challenges that I have within our own like local network here, like and with me streaming at the same time, it makes it kind of harder to see and probably harder to appreciate, because like the fast 3G comparison, like here's one with some real data and it's a little bit heavier. The fast 3G comparison is significantly more different between streaming with like real data and say like client-side rendering. Like this is with real data fetching over the network. Just to give like and with proper preloading in place. I probably should have used this example at the beginning. I was trying to show the difference, you know, with a controlled. But when you use real data loading, first paint happens here at 1162 and largest contate at 1274, and we're basically done our work here. Like hydration finishes like right over here, like we're around like 1.2 milliseconds for the streamed version. But when you do client rendering like Jamstack, you're not done. You're not done until, oh wow, 2.4 seconds. It's over a whole second slower on fast 3G. Right? It's like right, like it's a whole second slower. And async, you know, under this condition, is better than client-side rendering or client-side fetching, but it's still worse. Like let's run this one more time to make sure that wasn't, you know, yeah, okay, there we go. That's better. Yeah, so async here is actually very similar. So your standard, on a slow network, your standard Next.js approach, or Svelte kit, is going to be very similar in profile to the streaming one, which, or not that one, sorry, streaming one, which is this one. where it kind of all finishes up around 1200 milliseconds. The client-side Jamstack version is like twice as slow. And but as I said, the dynamic completely changes on the fast network, where async is much worse, and the client-side rendering actually beats it. This is something that I kind of learned early on when I was working on Solid. I was doing a lot of client-side rendering, and I was like, why do I need SSR? It's much faster to client-side render than SSR. But it's just because the solutions weren't using streaming. We send data in both cases, both streaming and async. It's just if you wait till the end, you're waiting to the end. You're hitting the bottleneck. Yeah, I mean, it depends, right? Client-side fetching on a slow network has to wait to process the JavaScript to start the fetch. So even a quote-unquote fast 3G network on a single request, no cascading, nothing fancy, we basically doubled our time. Streaming kind of lets you get the best of both worlds. It lets you do all the work on the server, but doesn't kind of block you from loading the assets on the client at the same time. That's really my whole point here. Obviously, I dwelled here on performance for quite a while, but I do think, like, I mean, I already showed you how much, like, client side is so much slower. But if you go the opposite direction, as I said, and I should have done this example in the first place, I'm kind of sorry about that. But if I go here and go, okay, now we're on a fast network, let's go. Client side, first paint, 55, largest contentful, 116, and the whole thing is done by like 140, right? Streaming, is going to look really similar to this. Sorry, that was weird. Oh, I was testing different modes. Crap. Damn it. This is the streaming example in just a second. Was I testing a different mode? Sorry. Okay. Let's go to the async. Streaming performs basically the same as client on the fast network, but look at the difference here. Everything's done, but it had to wait for 286 essentially. So even on the fast network, client side rendering, which had basically done all of its work. So this is not the fast network. This and I just showed it off a minute ago. Anyways, my point is that on the fast network, client-side rendering had already basically done all its work before async even started, essentially. So it's a big difference. It's a big improvement. Like client and streaming are best on fast networks. Async and streaming are best on slow networks. Only streaming is best on both. That's essentially it. That's it's not like it's like way faster in a lot of cases. It just covers the spectrum better. That's essentially the gist of it on the performance profiling. I might just move right. I did have a couple more things out. There's one more thing I wanted to show. We're done talking performance now on streaming. I think you kind of get the benefits of there. I wanted to kind of show. I wanted to show the streaming example again. Yeah. All right. I'll have the other one running. Show the streaming example again, and I want to show. I'm gonna throw up. Let me refresh the page. I have this one unminified a bit on purpose because I want to show you here. Let's do that. Let's go in here. I'm gonna put a breakpoint here because you can kind of actually see at each point how this resolves, right? First step, it was loading. Then when the first suspense resolves, we actually insert this in place, but it hasn't hydrated yet. Then when the second suspense resolves, we insert this in place, and then it finishes. And the reason I wanted to show this is what happens if there's an error while you're streaming. It's like, it's kind of an interesting problem when you have the page split across multiple places. And this is one of the things that we've been working on, because we didn't have error boundaries on the server for Solid. So I wanted to kind of, play with this. And like, obviously the simplest thing you could do is if you have a synchronous error, this should be hopefully pretty easy, right? Throw new error, right? And with a synchronous error, it is kind of simple, right? We build our example. We use streaming for this mostly. What am I missing? Oh, like an extra. Yeah, it's never gonna hit that, right? Okay, that's fine. Let's start. I'm gonna throw. Okay, not too interesting. And this one's always going to error. If I go to a different page and reset, it'll work fine. But my point is, this load, this in this example, because it happens during the synchronous rendering. Oh, interesting. Did I actually break the error boundaries? That's fun. This is my fault for messing with this stuff. It does seem to mostly be working. Okay. This is pretty easy to handle because it's all rendering on the server, and our rendered HTML essentially. Yes, but I've got a solution for that, and that's what I want to show off here, which is kind of cool. Because in the reason I'm showing the simple case here is because if we look at what gets streamed out this here, we just stream out the error boundary essentially synchronously. There's nothing fancy here because it happens synchronously, right? So we streamed out the error boundary, we hit it. But what's more interesting is what if the error doesn't happen synchronously? What if the error happens when we're loading information? What if it happens down here in that second suspense boundary when the first suspense boundary is already flush? What if I make this res reject, and instead of resolving it after 400 milliseconds, what if I reject it after 400 milliseconds? What if I go reject, right? What if I do this instead? Because you get the problem, right? It's streamed out the first one, and I didn't show you the structure of my app here, but error boundaries happen where read is. So this content's already going to be in the client, and this suspense boundary is going to trigger the error when it reads this data, the info down here, and the error boundary is all the way up here, outside at the top of our app, already in the browser. My luck is I've probably broken this since I was testing it because I've been working on some new stuff. But let's see if we can handle this. Let me show you that again. what we're actually doing is we're throwing the error on the server, and if it hits the topmost suspense boundary without hitting an error boundary, it actually throws the error across the network, and the client catches the error, and the client error boundary actually does the error boundary again. Pretty crazy, eh? This is what I've been working on. Yeah. This is one of the considerations that's coming in Solid 1.3 hopefully next week. So synchronous ones still render on the server, but our error boundaries can go across client server boundaries. It means that the error doesn't actually propagate until hydration time, but it is definitely a cool trick, right? I'm still ironing out the pieces, but essentially I was sitting there and I was like, how do I solve this, right? Like, there's a lot of talk. We have stuff on Marko where we talk about it, and you can do redirects and like full page reloads, because if the page is errored, then maybe you should tell the browser or something. But at a certain point, if you've already sent the page, you already sent the status, it's kind of on us. It's like GraphQL. GraphQL has the ability to error out completely, but it also, usually you just handle your errors fine-grained. I think if you get past that initial shell render, like, you've determined the main stuff, the person's authorized, whatever, you kind of got to the main shell render, and it errors at that point, then, it's kind of like what happens on the client. You can handle it piecewise. You can gracefully recover and navigate out of the situation. And that's kind of the idea here. Yeah. I'm glad you all like it. This is, as I said, handle both the synchronous and asynchronous cases, even with streaming. I wonder if I can show this in slow motion a little bit. If I show it here, we see it better. Because first, there, then there, then there. Yeah. See? How does reset work? Reset is something that Solid's error boundaries have built in, where it just tells it to try and re-render everything below the error boundary again. It was like technically you should fix the state before you do it if it's recurring, but you can pretend like if in our example here, let's pretend the error only happens on the server. I mean, that's kind of silly, but what if we were like, is server reject else respond? Let's just pretend like this was our code. Solid has like a is server that is exported from Solid.js web. Let's do this instead. If we did that, it fails on the server, but then when we click reset, it'll load in the client. Essentially, this is just client-side suspense. So just to kind of show you, usually you have to, if it's always going to error, then it's always going to error when you click reset because it runs the same code again. But because the code on the client's different than the code on the server here, we can kind of showcase this working. It's interesting. With the original streaming approach that was client rendered, this wasn't a problem at all. The big change in Solid 1.3 is we're doing HTML streaming. Originally, we only streamed the data, which means the client would render it. I need to test how that works with style components again, because the trick that we typically do is we flush the styles at the shell time, which means that the stuff that's lower down in the tree basically triggers the styles at hydration. So I need to see what that looks like in terms of doing partial. I think styling solutions are going to be the place where we're going to have to do the most work. Solid is will be shipping with a data only option, which preserves the current streaming behavior. So we can do that. But yes, this is definitely a place where we're going to have to work on, especially some of the CSS libraries, definitely. This is an interesting one, and I think generally speaking, it should be fine. We need to look at the fallbacks. I think the placeholders might be the one place that styling breaks. I use Marko's technique. We might have to revisit this. As I said, the HTML streaming is still has some cases that we have to consider. Yeah, I mean, yes, it is client-based for the retry because it's like the effects only run in the browser. There's really, but like you have everything you need at that point. Do you know what I mean? Like by the time you're there, you've already loaded the JavaScript anyways. There's no point going back to the server. Like you already have the stuff. Like in general, and I was kind of pointing at this, streaming HTML is good because it saves round trips and stuff at the end. Generally speaking, like doing stuff with JSON APIs versus going to the server with HTML, like there's not really a huge amount of difference. Like the JavaScript JSON stuff might even be slightly faster in a lot of cases if it's handled properly. But like if it was a case where like it was a partial hydration consideration, maybe, and as I said, a lot of people could do that. But I mean, you could also just in your error boundary just go reload the page. Like that could be what the error boundary does. The stream component failed to send data. Yeah, I mean, basically that would be handled like a client-side error because it's resolving a promise in the client. So then the client would, like, if it failed to send the data, I guess if it failed to send the data, hydration would hang. Unless it actually rejected, it'd be like a promise that never resolved, essentially, if we failed to send the data. Like if it failed, like actually errored, you'd be fine. But if it actually like just didn't send it, then it'd be like it'd be like just not like if a request timed out and didn't send it. But that's basically the error boundary functionality. It does both synchronous and async error boundaries across. Across, as I said, if it can handle on the server, it'll handle it and send it like I showed you. But like in this case, we didn't look at the network here. But if we look at the rendered HTML, what we're going to see here is that it actually got as far as like it sent the first bit, and then where is it? And then placeholder, and then it rendered the second bit and placeholder, and then it just finished by sending our error through. See our YOLO? It just sent our error through in the last script and triggered the error boundary. That's essentially what happened. So there's some refinement here. But I've got the core mechanisms working. I'm mostly just working on testing and bug fixing at this point. And I think some of the more next piece, and I've been, as I said, testing some of the CSS libraries is going to take a little bit of work here. But that's essentially, you can opt into the current behavior with data only, and obviously you can always just do async, to get suspense on the server still, essentially. So we have the three modes: no suspense on the server, suspense on the server, wait for everything to finish, and then suspense on the server. Actually, four modes: streaming, but just the data, and then suspense on the server streaming the HTML. So my hope is obviously that streaming HTML just becomes the de facto way, but I understand that there's still some work, especially with third-party libraries, that we're going to have to kind of round out. While we're in this demo, there is actually, I'm going to sort of remove all the errors here for a second. There is one more cool feature. Thanks. Yeah, I'm hoping this turns out to be a good pattern. There's one more cool feature that I wanted to kind of show off here, which is this one doesn't matter so much for all projects, but some of you might be familiar with Astro, and with Astro, you can have multiple routes, and our problem with async is they could collide with each other. So we've added a new feature in 1.3 where we can set a prefix ID on both sides. So when you hydrate, we can use my favorite ID. We can do that, and then when we server render, I'll just do the streaming example, for example. Where is it? Render to stream. We can also add our render ID, and if it matches, everything will hydrate as expected, which is here. So it's the window. That's interesting. It's like I accidentally closed the window or something, because this isn't the right window. This is Hacker News example. The window just disappeared on me. Okay, there it is. Yeah, I must have just missed it. Build example stream. Start example stream. Okay, beautiful. Okay. See, and this example hydrated perfectly fine, right? But if I mismatch the ID, essentially, and you're like, why would you do that? I just want to show, like, you can have multiple hydration routes now on the same page, not conflicting with each other, perfectly namespaced. So now if I do this, this won't hydrate properly. See how it's not updating? See how this counter doesn't work? It's an error, but essentially, my point is we'll be able to support async rendering in Astro as soon as they give us the ability to provide unique IDs from the renderer, which is something that I've been talking to them about. So I'm looking forward to that. I don't know if that feature makes sense, but it's basically just to support islands better. It's weird. I don't know why it's not opening the right window up ever. Okay, there it is. Okay, and one other thing to mark over here is update to the streaming API. I don't know if you noticed this. It's rendered to stream, options, and then pipe. And this gives us a lot of ability of when we send the stream, so we can wait to flush till the end or flush immediately like I am here. And I've set it up so that it's the same API for both web streams and for node streams. For node, you use .pipe. For web streams, you use pipe2, essentially, and it pipes to a writable stream. So in this case, pipe is just our response, like from Express. But on a Cloudflare worker, you'd pipe to the writable side of one of their transform streams or whatever. So essentially, kind of unified the API. That's another big one here. Yeah, how does streaming handle meta async page styles and assets? There's some great write-ups that I love that are coming up from the React team on this. Generally speaking, you've only got two options here. You either figure it out on the synchronous part of render, like before you pipe it through. So essentially, on that first render, collect all the async stuff. So, as you go through your routes or, start your route loading, what page you are, set all the meta tags. Or you're going to be setting it in the client when it hydrates. That's basically the two options you have. Streaming, there is no real way to get around it. Like if you want the right stuff, you basically have to do it up front. You could, if there's some stuff you could load, you could, but the problem is the second you stop things to load data, you're blocking the stream and you're back to async again. You're basically missing the point. So if all possible, you don't want to wait before you start streaming back the content. And obviously the head is what streams first. So that's kind of the conflict. Either you kind of got to pick whether you have a more performant page and you stream the stuff with the headers that you have, or you block the page and wait till the end. Unfortunately, there isn't really a great answer here. Think of offloading client-side rendering. Oh, okay. Yeah, that's interesting. I see what you're saying. Yeah, I mean, here's the thing. If you already have the content in the browser, like client-side rendering in the main thread is the fastest, most performant way to do stuff. There's concerns about blocking, for sure, but generally speaking, like it's always faster. Web workers can't write to the DOM directly. You have to like go through a bit of a song and a dance and like encode it and send it back. Like essentially, the main thread has access to the DOM. So like they're doing cool stuff quick and stuff with like Party Town and like playing around with this, but like performant rendering only happens on the main thread. Manually hydrating is another question, which is interesting. As I said, right now we're still kind of just hydrating top down. I've thought about patterns to hydrate, as you need it. One of the as your project gets bigger, it definitely is a consideration, the hydration costs and how lazy loading plays in. I'm just going to need to explore it more. Right now, on obviously the small demos where you can see quite notably like a 400 millisecond gap, for hydration when you using React. Like with Solid, it hydrates almost immediately. Our hydration costs are actually relatively cheap because of the way we render. It's all fine grained, and we just literally just we hook up. We just run like some of the fine grained stuff. We don't like build a whole VDOM. But that being said, like obviously you always want to do less. With the thing with you can get better. Yeah, I mean, I suppose what it depends on the network speed. As I was saying, I was beating server rendered stuff with client side rendering for the most part, just because of like the delay, like where they have to actually wait to do this stuff before they start sending other assets and then loading in and causing the waterfalls and stuff. I'm just saying, like, how does the worker get the content? Like, like I guess I'm thinking mostly first page load, and then I'm thinking like after the fact, um, like like it needs to load at some point. Maybe I'm just not quite following. I think it's interesting, and Marko, we were thinking about this, is when you have a framework that's primarily set up for uh, server-side rendering, it might be interesting to just move that server closer, like put it in a worker. So that we're already moving closer on the edge. Why don't we just take it all the way to the worker? But on the other hand, I feel like the benefit comes mostly if you can unify the paradigm. Like it's always works like that conceptually, because I said client-side rendering is also can be very, very fast. Anyway, okay. So we've talked about the streaming APIs. We've talked about the what is it called? The render IDs, essentially the new ability to do async islands. We talked about error boundaries. There's one or two other things that I want to talk about from Solid 1.3. Let's just look at let's just look at it for a second here. Solid. I got the change log. I'm still working through bugs here, as I mentioned, but if we go to the next branch, you can see what I've been doing. And often when I get close to release, I start putting, I guess I didn't put it in the nested, it's the top level package. I start putting stuff in the change log to give stuff. So we talked about HTML streaming and the new streaming APIs. We talked about error boundaries. We talked about isolated. Yes. The next thing I want to talk about actually is a really cool thing. Said here is universal reactivity. This is the last big feature. Most of the other stuff we've been doing is like a lot of work on TypeScript support, and some improvements to source maps. But I think, and there's a bunch of bug fixes, but I think this one's a really interesting one. And I'm going to pull up a code sandbox to show you what I'm talking about. I shared this on Twitter, and people were kind of mind blown. The creator of Cairo, Shane, he was like, I don't know if any of you have ever tried to use an external store in a framework, right? If you've ever seen like MobX, they have this ability to like make classes reactive. You just go make auto observable, and then you can essentially like wrap normal property access getters and stuff to make them reactive. It's kind of a cool thing. But most of the time, if you were to go through the process of like taking a state library like MobX and using it in React, or using it using it in something React, you'd usually have to wrap your component in like an observer or decorator, kind of wrap it in an effect, because they need something to track, and that generally causes them to re-render whole components. If you're not familiar, I apologize. I don't have an example of that in front of me right now, but essentially, actually, maybe I can see MobX React. Just pull it up to kind of show you what I mean. Yeah, here's the timer, and then essentially you use this observer and you actually wrap your component in an observer, and then it reruns the whole component. The problem with reactive libraries playing with other reactive libraries is, what if you don't want to re-render the whole component? Like, often you have no reason to use MobX in Vue or Solid because we have our own state management, we have our own reactivity. Why would you do that? But just like MobX state tree, there's some interesting applications like specific state patterns. And the thing is, with React, you might just wrap the whole thing and re-render everything. That's not going to work in a more granular system. And what you end up happening, and it's very similar to when you interact with MobX, is you'll essentially have to map each thing to a signal. So you maybe like this is a class, which is nice. It's like almost like a proxy. It has like the whole thing, but like quite often you'll have to like you make like a use observable hook, and inside that you'll subscribe to the MobX observable, like, essentially, and have it write to a signal. Like, it'll look something, if you're MobX program, you might have seen this before. Auto run, and then you'll be like, whenever timer dot seconds pass changes, set signal. What you'll do is you'll write a wrapper kind of like this, and maybe it'll look like this. Use observable. Okay, let's pretend this is our use observable function. And this is set, and then you'll return S. And so let's say you make your new timer, and then you go use observable timer dot seconds passed, and then you'll be like, let's call it seconds. And then you'll put it in here, and you'll use it. and it works, and you click and you reset. This is the typical way. And let me get my screen a little bit bigger so you can see it a little better here. But this is the typical way that I'm going to comment this out to prove that I'm not doing any tricks. This is the typical way that you would do this in most libraries. Let me see if I can save this. So I probably don't want to save it because there are people who should fork this. Anyways, you make a special wrapper. You use a signal. You set up an auto run, and then everywhere you want to use a mobx variable in Solid, you wrap it in a use observable thing, and then you get a new signal, and you use that in your template. This is the standard process of that. And then if you want to use different things in mobx, you might have a whole set of wrappers like use computed, use observable, use auto run, or whatever. Like it's kind of this awkward process of wrappers, and to be fair, it's very similar. Like it is similar in other libraries that kind of use a hook wrapper when it doesn't fit the paradigm properly. Like even React, you just make a hook, and then now it's in React state essentially. But what's really cool about this thing that Shane came up with here was he was like, what if we just registered it right at the beginning and made it so that anytime Solid makes a computation, it can listen for non-native atoms that come from an external system. Essentially, what if you could just provide a simple config where you return a track and dispose lifecycle functions, and when it tracks, your only responsibility is to set up mobx's tracking and make sure that you return the result of that function, and then have this for teardown. Really simple API. So whenever you make a new source, create a new reaction, track, and dispose. And if you could do that, well, now when we get a mobx observable here, we can actually read it straight inside the JSX, right? Because it's actually Solid's effects and computations are now aware of mobx primitives. It doesn't matter what it is. It could be create effect, right? We could console log it too if we wanted to. Solid now knows that mobx observables are trackable. And obviously, see here is console logging. Obviously, but you can also use, because you're using mobx, you can also use the mobx's ones too. You can do like this. I have to import it from mobx first, but we can also go auto run. There we go. And it's still working. Essentially, you can basically write your whole app in mobx with the JSX and not even think about it, or use Solid's primitives and use them interchangeably, because basically their atoms can be read by the others' computations. Technically, the mobx ones won't be able to read the Solid primitives, but the Solid primitives will be able to read all the mobx ones. It's kind of cool. So if you had an app written in mobx state tree, now you can you could just pull it in and drive a Solid app without even using any of Solid's primitives. Technically, this is going to be a little bit less performant because there's this like little overhead. But if you're just using mobx's primitives here, Solid's subscriptions will just be the single signal. Yeah. So I mean, it's not really it is an overhead cost, but if you don't actually read from it, it's not. We don't create the subscription arrays, which means that we don't actually. It's not really that expensive. So, I think this is a good option. This is still considered experimental because we haven't figured out how this works with concurrent rendering completely, but we'll be experimenting with this, and it's really kind of a cool feature to be able to use any reactive library almost natively in Solid. All right. Yeah, I think that mostly covers the 1.3 release and mostly covers the streaming topic. That is most of actually what I wanted to cover today. I've been doing a lot of streaming demos and stuff. I did want to show off here for a moment. I've showed off enough timelines, obviously. But what I wanted to show is that React did update their streaming demo, the Next.js streaming demo, from a little while back. So I think if you haven't seen it, they've actually improved the performance considerably on this Vercel server component demo. See the new placeholder they have? They got rid of that cascading placeholder, and it's much nicer now. The only problem is they seem to have some kind of HTTP caching going on. When I refresh, I don't see the streaming again. I'm pretty if I wait like 3 or 4 seconds, it'll show it, or if I like a little bit, it'll show it. But even with everything disabled, they're doing, and the service worker disabled, they're doing something where the streaming doesn't come through. It's quite possible that they're caching the HTML. And as I said before, when you have streaming like this, if you have the data immediately, you don't see the loading state. So I'm pretty sure that's what's happening here. But if you look at React, it is, and what they're sending over the wire, just in case you're curious as well about what React streaming solution looks like. I'll spit this out. You're going to see a lot of the similar kind of stuff. You're going to see some CSS coming in. They're inlining the styles, which is good for performance. But the thing here is, yeah, where are we? At the bottom here, we should see this is their script. Here's their data, the script to do the replacement call, and this is how they do the element replace, this code snippet here. And then what I wanted to say here is the majority of the content here should be coming in through, let's get up to the top of the stories here. They should have, yeah, this is interesting. I don't see it, which is interesting. There should be, I'm trying to find the insertion point for, yeah, here it is, div hidden. So everything in here is the part that's streamed in after the fact, and then this is their placeholder stuff here. See, template P1 is their placeholder, and then div hidden, and then they probably insert this in, very similar to what we're doing in Solid. Marko works the same way too. There's some interesting stuff going on, but generally speaking, it's a very similar mechanism. Let's see if I refresh, if we can see the placeholder again. See, there's the placeholder. Yeah. So, yeah. Could something similar to the last feature be used to seamlessly use solid components inside Vue with Vue primitives? Well, I don't know if the rendering difference is the challenge. We could probably natively use Vue and Solid because the reactivity works like that. Right. But like rendering is different. Like Vue has a VDOM, so it's kind of like with React, we have the same problem with like what's it called? Not transclusion, like inserting children and whatnot. Like it even if, I guess the interesting part is you could share state easier. Like if you had but you wouldn't have context to use it. So, but you could probably use Vue's reactivity pretty natively to have solid components like run off the same global store. So, I mean, that's kind of cool. How do you handle scroll position with streaming? I wonder about page refresh and lots of content. Streaming, as I said, is just pulling in the HTML response. So I imagine if you're interacting with the page a bit, like if you're adding stuff to the middle of the page, it's going to jump much like client-side rendering when you exit the page. Hopefully, you create your placeholders to roughly be the same size of your content, but it behaves a lot like client-side rendering in the sense that the hidden content's not going to affect too much because it's like removed out of the flow. But any content that you then insert is basically very like client-side rendering is kind of jumping into view. Back and forward navigation, well, it depends on how you're handling it, right? If the browser is handling it, like generally speaking, like all the examples I've shown, same with React, are single page apps. So, like, if you move forward and back after that fact, you're doing everything in the client. Like it turns into a single page app. Obviously, if it's the first page you can hit back, you're going to leave the site. But if generally speaking, if you go into the site, click onto another tab, and then click back, you're not streaming again. Like everything's client side. The streaming is literally just the serving of the initial HTML file. So it's not unlike the experience, as I said, of client-side rendering for the way that it kind of pops in, and then it goes kind of full client-side after that point. Generally, I mean, it depends on the solution. Marko doesn't, right? Marko's a multi-page app, so when it streams, like you stream again. But I mean, the cool thing, as I mentioned before, streaming is if the page is cached, it does have the ability to like play pretty quickly, so you don't even see the loading states. Basically, all HTML is streamed in a sense. It's the out of order stuff that messes things up when you do the insertions. So it has all the same characteristics of inserting HTML when you insert with JavaScript because it is JavaScript, essentially. Yeah, so as I said, big ups on them improving this demo. I did some page insights and stuff, and the performance here is much better than where we were before, right? For this one. When I covered this 2 weeks ago, they were hydrating in about 1.8 seconds on mobile. And okay, well, I mean, the time to interactive is still kind of slow, but the way better first contentful paint, way better large paint. And yeah, I mean, I guess it's still React, but this is where the benefit comes in streaming. Getting the content sooner. Sure. While I'm answering questions, what's the idiomatic way to track the previous value of a signal in solid? That's a good question. It depends on where you want to use it. Generally speaking, Solid's mostly concerned with synchronization, so getting the previous value requires a little bit of extra work. Things like memos and effects have this have the ability to how should I put it? They have the ability to pass the previous calculated value back in, like they're all reducing. But generally speaking, previous values of signals are tricky. Like you'd have to store them somewhere or put them in a different signal, essentially. You don't have to worry about signals like redrawing the page. Like it's not like React where like, oh, if it's stateful, then you're going to redraw that component. Signals can work in isolation. It's only the things that subscribe to them that matter. But for wiring the past, you kind of have to do the specific wiring, right? Yeah, I mean, there aren't really refs in solid. Like they're just refs in solid are just a variable. So because the thing doesn't re-render, like you don't have to store it in a special object. You can literally just assign it to a value, and that's fine. Like we don't have use ref. The components don't rerun, so it's just let whatever. So you could always get the previous value. You store the previous value like that. Things like concurrent rendering could cause some tearing theoretically. But yeah, I'd have to understand the use case. All right. I think that's good. Oh, I'd be interested in reading that. One of the things is like I said, we've been using streaming a lot in Marko with MPAs, but I think part of our saving grace is because we use MPAs, like full page refresh and stuff. Like you, maybe the state of things doesn't get as convoluted. Be interested in that. But most of there's a thread right now going on, and I think let me see here. Go to GitHub. Some discussion that's going on that I thought was interesting. Maybe I can't. Yeah, maybe I'm not going to find it right now. But there's a whole thread about. Yeah, I'm not going to find it right now. There's basically like a whole thread about us kind of talking about different error cases and different potential ways of handling them. Yeah, it's probably worth sharing, definitely. Yeah, the comment section definitely doesn't. But do links work in chat, or do they just get blocked? Anyway, you can always drop it on our Discord if possible. But yeah, I'd definitely be interested. I think the thing is, streaming opens up a different set of questions because there's a whole bunch of different constraints. And as Sunil was saying, in terms of like different like libraries have to consider, because it's not just the frameworks. Like I was working on GraphQL for Marko to support streaming, and the problem was they assumed that all the hydrated data was there up front, which made things really difficult because they were like they assume that you gather all the hydrated data at the end of rendering async, like everything, and then it's there before you start any hydrating, and like that's not how streaming works. I had to kind of create an incremental cache and stream the data as it completed, and then restore the data for the cache as it finished up on the client, because like it just tools like that just aren't built that way today. React's working with them, but I think that's like maybe that's why I was like a little less concerned on some of the third-party libraries, just because it's not just the changes that we do with the framework in terms of supporting them. It's just like they actually have to change to address this. This streaming stuff is potentially a bigger change than even all the concurrent stuff people were worried about. Obviously, we ease into it and take our time, but essentially, it does. Maybe this is largely why it keeps on becoming that forgotten art, so to speak. You have to approach things a little differently when everything's kind of concurrent and non-blocking. So like libraries will have to change with it. Anyway, yeah, this is good for today. Unless we're going to try and drop that one article over chat while it's still open, I'm gonna call the stream, and we'll see. I probably won't do one next week. It's Christmas Eve, and then it's New Year's Eve, so it might be a couple weeks. I'll see if I can stream midweek, maybe a different day. So keep an eye out for it. But I think we've covered streaming as far as we're going to cover it today. Obviously, a lot of looking at some of the performance stuff, but I think it's really cool, and I think there's a lot of potential here. But yeah, it's going to take a little time for it to go mainstream, but who knows? With React, kind of leading the way, I think there's a real potential here. All right, perfect. You all have a great weekend. Till next time. See ya.